So we have talked about the definitions, talked about the relation. Guys, if I am talking, should you be talking? No. All right, so we've talked about the relation between radius and diameter. So right here below that, all right, it shows Micah and his friends work at a tire factory. The factory manufactures several different size tires for different vehicles. Fill out the table below to show how the diameter and the circumference of the tires are related. Now, all we're doing here is just setting up a ratio. What is a ratio again? Does anybody remember the formal definition?
Like 32
even.
No, it's a comparison of two things. Okay, so if I'm setting up a ratio, all I'm doing is comparing the circumference to the diameter. So started with circumference over diameter. All right, so what is my circumference here? 56.52 over 18. Okay?
And that's it?
That's all we're doing right this second. Okay? All right, so what is my circumference here for the car? 75.36 over 24. Okay, what is my comparison for the dump truck? Over 36. Okay, so when I have a ratio, because isn't that how I set up to find scale factor? I can simplify it by dividing it. All of those things, right? So could I divide them to simplify it? Yes. So let's start with that first one. 43.96 divided by 14. Okay. Can 14 go into 43?
Yeah.
3 times.
Yes.
3 times? What is 14 times 3?
20, 30, 32. Yeah. Is it 42? 14 times.
42. Because times 3 would give me 12. Carry my 1, it'd be 42. Okay. So I have 1 left over. Well, how many times can 14 go into 19? Once. How many times do you think it could go into 56? What times 4 gives you something that ends in a 6?
8. I mean, at 9.
Okay, that's way too much. Think smaller. 4. It gives me exactly what? 56. Okay, so when I simplified my ratio, it was 3.14. Now, just to save us some time, I'm going to show you what would happen if we simplified all of them. Okay, so I did 56.52 divided by 18. What did it give me?
3.14.
Okay, so the next one, if I did the next one, I think somebody's at the door. 75.36 divided by 24. What did it give me?
0.130833.
No. 3.14.
The other way. Oh.
Well, that's what we're trying to figure out, right? 3.14. Okay, so it asks, what patterns do you notice regarding the circumference and the diameter? So when I'm looking at the circumference in comparison to the diameter, what happened every single time? We got the same answer. We got 3.14. So right here, when the circumference is divided by, what did we divide the circumference by? Yes, by the diameter. We get what? 3.14. Okay. Does anybody know what 3.14 is a shortened approximate version of?
3.1.
No. Of what?
Pi.
Pi. How many of you have seen this symbol? Okay. So 3.14 is used for pi. All right. Because we don't have a calculator, because let me just tell you, next year when you get this fancy calculator, there is a pi symbol on there. You can't really see it, but you see that little blue pi symbol? So all you have to do is that, and it puts the pi symbol in the calculator for you. But since you don't have a calculator, we need a shortened version of pi, because pi is an irrational, never-ending decimal. You see that? It just keeps going. So this is nice, the nice version of pi that we like. Okay?
Could you divide?
Never ends.
Could you divide something by pi?
Well,
Or would it not be possible?
3 divided by pi. It just gives me
A huge never-ending number.
a never-ending number. Now, what do you usually do when you have decimals that keep going?
Round.
You round. So if you ever use that on your calculator, yes, you would just round.
How does it never end? The numbers just keep generating?
Yeah. Yes.
Have you ever thought about how a calculator actually works?
No.
Continuing. Okay. So here's a question for you. If I divided my circumference by the diameter and got pi, how do you think, if I didn't have the circumference and it wanted me to find it, how do you think I would solve that? Could I multiply what?
The radius.
No. What happened when I divided them? I got what? Which is what? Pi. So what do you think I would do to solve for circumference? Pi times diameter. Okay. So my formula here, I can do two formulas. So if I'm trying to find circumference, I can do pi times the diameter, like we just said. Okay.
So we can do that on each problem.
Almost, because maybe I have a circle like this, and does it give me a diameter? No. So if I didn't have the diameter, what do you think I would do to the radius? Multiply by what?
Pi.
No. Okay, let me listen to my words. If I don't have a diameter, okay, y'all told me that the radius is half. So to find the diameter, you would do times 2. So your would be 2 pi r. You would have to multiply it by 2. Okay. And then it says pi can be approximated to what? 3.14. Okay. So when I have a formula, guys, y'all should appreciate formulas because there's no confusion on how to solve a problem. We literally plug the numbers in. That's it. There's no questioning, am I using the right numbers? When we did similar figures, am I using the right sides? Because I know what a diameter is. I know what radius is. I know what pi is. Okay, so right here, it gives me, does it give me radius or diameter? What is that?
Radius.
So this is my radius. So I'm going to use this formula, right? Okay, so it wants me to plug in values. Anytime it says plug in values, values means numbers. We're plugging in our numbers for our symbols, our variables, okay? So this would be 2. What value do I use for pi? 3.14, because that's what we set up here, right? Okay, so then what value am I using for r? 6. Okay, so when it says in terms of pi, it basically wants you, if you can, to condense this. So can I multiply 2 by 6?
Yes.
What do I get?
12.
Okay, so I can say circumference equals 12, and then it says in terms of pi. That means don't put 3.14. I'm going to put my pi symbol. Can I solve that now?
Yes.
How would I solve it?
You would have to multiply 12 by 3.4.
3.14
My bad.
times 12. Well, 4 times 2, 8. 2 times 1, 2 times 3. Okay. And then everything times 1. So I have 8, 6, 7, and 3. Am I just going to put 3,768?
360. 76.
It'll be 37.68.
37.68. Why is it 37.68? I have 2 decimal places here, so I go 1, 2. 37.68. What unit of measurement did it use? What unit of measurement did it use?
Inches.
Inches. Because remember, the circumference is just the perimeter around the circle. Okay, so what part of the circle does it give me in circle 2? The diameter. So what formula would be appropriate for this?
C equals pi. C equals 2.
Pi d. So I'm plugging in my values. Okay, so my numbers. What number do I use to represent pi? What number do I use for my diameter? Okay, how would I write that with a pi symbol? It's not a trick question. 14 pi. Okay, I'm glad you said it like that because it's basically just etiquette, math etiquette. When you have a symbol, you have a variable, it comes last. It comes after the number, not before. Okay? Don't ask me why. I didn't make up the etiquette for math, but we're going to follow it. Just kind of like good manners at the table. This is good math manners. Okay? Okay, so circumference. Can I figure out my circumference? 3.14 times what?
28.
No, 14. I didn't have to do anything times 2, did I?
It should be 43.96.
So, 5. What'd you get, Cooper?
43.96.
Good. 2 decimal places, move it over twice.
So when it's
What measurement? What, Trey?
when it's the diameter, you just leave it and multiply by 5.
Mm-hmm. The only reason with the radius that I have to do times 2 is because I would have to do it twice to find my diameter. Okay? So my formula, it gives me the radius, so which formula would I use?
C equals 2 pi
R. Okay? My values, obviously 2 stays there. What value do I use for pi? 3.14. What is the value of my radius? 3.5. Okay, so in terms of pi, this just puts it more simple. 3.5 times 2. What is 3.5 plus 3.5? It's 7. So 7 pi. Can I multiply? 3.14 times 7. I'm going to give you a minute to work it out.
uh, 21.98.
Good. 21.98 what? Meters. Okay. A Ferris wheel. What shape is a Ferris wheel? Shocker, right? Okay. It travels in a circular motion and measures 40 meters from the top car to the bottom car. So that 40 is representing what? If I go from the top to the bottom, it's diameter. So when it says what is the length of the diameter, well, it's 40 meters. Okay, what's the radius? What did we say the radius is in comparison to the diameter? We said half. So what's half of 40? 20. Okay, a car travels one time around the Ferris wheel, so it goes all the way around. So what am I looking for? Circumference. This wants to know my circumference. How many meters did it travel? So what would I have to do?
40 times 3.14.
Yep, 3.14 times 40. Okay, so 3.14 How many decimals do I have?
2.
2. So my answer is 0.6 what? Meters. Good. Not too bad, right? Okay, now this one you have to really read because a lot of the times we understand the topic, but we just don't read the question carefully, right? Okay, so on another Ferris wheel, a car will travel 100.48 meters to go once around the wheel. What is the height? So what did it give us?
The circumference.
So if our circumference, and it's asking for diameter, is pi times diameter, it gave me my circumference, so I have 100.48. What other measurement do I know? Obviously, would I solve for pi, or do I know pi? I know pi. So what am I solving for? What is the height from the top to the bottom? So top to the bottom is the diameter. I just divide. What do I divide? 100.48 divided by 3.14. Can't have a decimal, so what do I have to do? Twice? Twice. Okay, that looks kind of gross, right? But let's think about this. 300. 300 times what would get me closest to 1,000? We're estimating right now. Because 300 times 3 gives me what? And that's as close as I'm going to get to 1,000. Now, so I can do 314 times 3 because that's what we said estimating would get me closest. Did that get me as close as I possibly could? 942. So times 3. Okay, now I have 8. Okay, well 300 and 600, that would give me 2, so I'm going to do 314 times 2. Looky there. You see how estimating helped me? And we've done estimating? Yes? So my diameter is equal to 32 meters. No, because we moved it out of the way, so we don't have it anymore. If I needed to